Hey guys, it's Dave here from Creative Path Films, and today we're exploring the wonderful world of film lights. Today, you're going to learn about the four most common types of lighting fixtures used in film. I'm going to give you a brief explanation on how each of them works, as well as the key differences between them. We'll be talking about tungsten halogen, HMI, fluorescent, and LED lights. All right, let's get into it. Let's start with tungsten halogen lights. Tungsten lights have been a staple in the film world for a very, very long time, and it's easy to understand why. They're simple, fairly affordable, and they give you beautiful full spectrum colors with a CRI score of 100. When it comes to that beautiful quality of light at 3200 degrees Kelvin, nothing quite beats tungsten lights. So what's the downside? Tungsten globes are very inefficient, especially when compared to some of the more modern light fixtures out there. This inefficiency results in really large power draws, and up to 80 to 90% of that energy is being wasted on heat. As a result, these globes get very, very hot. The bulb themselves often reaches temperatures in excess of 500 degrees Celsius. All right, so how do they work? Well, tungsten globes consist of a tungsten filament, which is seated inside a quartz glass globe, which is also filled with pressurized halogen gas. This gas serves a couple of functions. The first is it increases the lifespan of the globe by recycling halogen back into the filament. It also allows the globe to operate at higher temperatures, thus increasing the output as well as increasing the color temperature. Tungsten lights have a color temperature of 3200 degrees Kelvin, compared to regular household incandescents, which have a color temperature of 2400 to 2800 degrees Kelvin. Despite being a little bit outdated, I still own and use a number of tungsten globes. They're, in my opinion, still the best looking 3200 Kelvin source available anywhere. The light they produce is really beautiful, but unfortunately, the heat does make working with them a little bit difficult, particularly in the summer months and in enclosed sets. Some of the more common brands of tungsten lights that you might find on sets are Arri, Mole Richardson, Ionaro, and Dito Light. There's also quite a few generically branded tungsten lights out there as well. Tungsten lights have a couple of different varieties. The main ones are open face, par, and Fresnel fixtures. All right, now on to HMI. HMI stands for Hydrargyrum Medium Arc Iodide. Hydrargyrum? Hydrargyrum. Fun fact, hydrargyrum is Greek for mercury. These lights are another staple in the film world and put out a lovely 5600 Kelvin daylight source. HMIs are also 4 times as efficient as tungsten lights, giving you 4 times the output per watt. This does come at a cost, however, as HMIs are incredibly complex and therefore quite expensive. They're in fact the most expensive type of fixture that we'll be talking about today. And unfortunately, once you own the light, the replacement bulbs don't come cheap either. HMIs work by mixing a mercury vapor with metal halides within a quartz glass bulb. Inside the bulb are also 2 tungsten electrodes, and they're spaced just far enough apart so that when a current passes through them, it arcs across and jumps from one electrode to another. This arc of electricity excites those mercury vapors and the metal halides to produce light. These gases do, however, take a little bit of time to warm up, so you will have to wait for these lights to get up to their proper output and color. The color temperature and CRI of HMIs is determined by the specific mix of chemicals within each globe. So this is why producing them can be quite complex. The mercury within the bulb will also start to burn off slowly over time. This means that as they age, the bulb's color temperature will actually shift towards different colors, meaning that you'll have to eventually correct this with correction gels. HMIs also need an electrical ballast, which helps to regulate the voltage and limit the electrical current. Most modern HMI ballasts are flicker-free, which means that you can shoot at higher frame rates, but not always. So this is always something that you want to check. Like tungsten lights, HMIs also come in open face, par, and Fresnel varieties. The most common manufacturer of HMI is Arri, but there are a couple of other brands out there as well. These include Film Gear, Silver Bullet, and K5600. Next on the list is fluorescent lights. Like HMIs, fluoros also use a mercury vapor within the globes, but this time it's a low pressure vapor. When the vapor is excited by an electrical current, what it does is it produces a shortwave UV light. This UV light activates a phosphor coating on the inside of the globe, which makes it start to glow, producing light. Although fluoros are more expensive to build than tungsten lights, they are much more efficient and have a longer lifespan. They do, however, have a much lower output than both HMIs and tungsten lights. The biggest downside to fluorescence is that it can be difficult to find bulbs with a high enough CRI rating for film and video, with Kinoflow being the brand that's the best at 95 CRI. You can also find bulbs in a variety of color temperatures, so you can get fluoro lights in tungsten, daylight, and in the middle at about 4500 Kelvin. Fluoros are also very susceptible to flicker. They have ballasts that operate at either 100 or 120 Hertz, depending on where you are in the world. So in order to avoid flicker, you have to shoot at a frame rate and shutter speed that is a multiple of this number. To give you an example, for a 100 Hertz ballast here in Australia, I can safely shoot at 25 frames per second, 50 frames per second, and 100 frames per second without any flicker. Like HMIs, fluoros also need a brief warm-up period, though much less than HMIs need. Fluoro globes are also considered a hazardous waste and should be disposed of carefully because of the mercury vapor. You should also be very careful when handling the globes because if they break, these mercury vapors are released into the air and you should evacuate the room immediately for a set period of time. The two most common brands of fluorescent lights are Kinoflow and Light Pro. Last on our list is LED lighting, which is quickly becoming the new standard for film and television because of the low cost, incredibly high efficiency, and accurate colors. LED stands for light emitting diode, and you can find LEDs in a variety of different styles, including surface mounted diode, chip on board, and multi-chip on board. LEDs produce as much as 200 lumens per watt, making them the most efficient type of light that we've explored so far. They can also reproduce a broad spectrum of color temperatures as well as any hue in the RGB spectrum. This makes LEDs incredibly powerful and versatile as a creative lighting tool. Good quality, high output LED fixtures are getting smaller and cheaper every year. And because of this, they're quickly replacing every other type of light available. Now, I tried looking into how LEDs actually work, but frankly, my brain kind of melted and it went straight over my head. In simple terms, they're a semiconductor device that emits light when an electrical current passes through it. If you want to know more than this, feel free to look it up and maybe it will make more sense to you. As you can imagine, there are a broad range of LED manufacturers out there at the moment, but a couple of my favorites are Aperture, Nanlite, Godox, and Falcon Eyes. Well, there you have it, guys. That's it for our video on the most common types of film lights and how they work. If you learned something today, make sure to let me know by giving this video a thumbs up. And if you'd like to learn how to put your lights in a practice, check out our film lighting techniques playlist here on YouTube. As always, if you'd like to see more videos just like this one, we put out videos every week, so make sure you're subscribed so you don't miss out. Thank you so much for watching, guys. I hope you have a wonderful day and we'll see you in the next video. Hydrogyrum quartz glass bulb. Get your words out. Yay! I'm excited, vapors! I'm shining brightly. That was weird. I don't know why I said that. HMI stands for Hydrogyrum Medium Arc Iodide. Yes!